Welcome to the Mathematics MI channel. In this video, we are going to evaluate another interesting infinite sums. Here we have two questions. Okay, first I'm going to take this sum is equal to S1 and this sum is equal to S2. Okay, what do you think? How to begin? Okay, first I'm going to start with the general integrals. Integral from 0 to 1 x to the n dx, and we know the general power rule x to the n plus 1 over n plus 1 from 0 to 1, and if we apply limit here we have 1 over n plus 1. Okay, then if we take integral from 0 to 1 x to the n plus 1 dx, we know this is equal to 1 over n plus 2. Also, if we take integral from 0 to 1 x to the n plus 2 dx, we know this is equal to 1 over n plus 3. Well, then here we have 1 over n plus 1 minus 1 over n plus 2. So 1 over n plus 1 minus 1 over n plus 2 plus 1 over n plus 3 minus this is going to infinity. And now we can represent this series by using integral. So integral from 0 to 1, now instead of 1 over n plus 1, we know integral of 0 to 1 x to the n, then x to the n plus 1. So we can write x to the n minus x to the n plus 1 plus x to the n plus 2 minus so on here dx. Okay, now here we have alternating geometric series, and we know this is equal to 0 to 1 x to the n over 1 plus common ratio we know x. So here then dx. Okay, then our sum we can write S1 is equal to infinite sum n is equal 1 to infinity. Here we have 1 over n, so 1 over n. Now instead of this part we can write integral from 0 to 1 x to the n over 1 plus x dx. Now we can switch integral sign and sigma notation. So here integral from 0 to 1, here we have 1 over 1 plus x, 1 over 1 plus x, sum of 1 to infinity, then here x to the n over n, and here dx. Okay, then now this is equal to this is a very famous infinite sum, and we know this is equal to minus times natural log of 1 minus x. So we can write minus integral from 0 to 1 natural log of 1 minus x over here 1 plus x dx. Okay, now we have another interesting integral, and in a previous video, yesterday video, I solved this integral by using two different methods, and we know the answer is here minus sign, and here we know this is equal to 1/2 natural log square of 2 minus theta of 2. Okay, if you like to watch that video, I will add the link in the description and also make a card. So now we should multiply by minus sign. So we have 1/2 times theta of 2 minus natural log square of 2. Okay, this is the answer. Now we are going to find the answer of this series, second question. So we know our infinite series S2. Now we can write S2 is equal to here we know same pattern, because 1 over n plus 1 minus 1 over n plus 2, 1 over n plus 3. So we know we can represent as an integral. So 0 to 1 we know x to the n over x to the n over 1 plus x dx, but here we have square, so we have power of 2, so we can write this is equal to integral from 0 to 1, same integral, but I'm going to change the variables, so y to the n over 1 plus y dy. Okay, then how to evaluate these integrals? Okay, here now we can write integral from 0 to 1, integral from 0 to 1, here we have 1 plus x, 1 plus y, so 1 over 1 plus x, 1 plus y, then here x to the n, y to the n. So here s2, I forgot the for sigma notation, here we have 0 to infinity, sorry, then we can switch the sigma notation, so here we can write infinite sum 0 to infinity, here x to the n, here y to the n, so we can write xy to the n dx dy. Okay, then again we can write here integral from 0 to 1, integral from 0 to 1, here 1 over 1 plus x times 1 plus y. Now here we have 0 to infinity xy to the n, and we know this is equal to 1 over 1 minus x. This infinite series is equal to 1 over 1 minus xy here, because here xy, so 1 minus xy here dx dy. Okay, then I'm going to write now here integral from 0 to 1, 1 over 1 plus x, then integral from 0 to 1, 1 over 1 plus y times 1 minus xy times here dy, outside of the brackets, parentheses, here dx. Okay, then we can write now this is equal to integral from 0 to 1, 1 over 1 plus x, then here now we can find the partial fractions, so I'm going to use a cover method, so we can write here integral from 0 to 1, first I'm going to write 1 plus y. Now instead of y we should plug in minus 1, so if we plug in minus 1 here, 1 over 1 plus x, so here we have 1 plus x, here 1 plus, now I'm going to write 1 minus xy. Now instead of y, 1 over x, so if we plug in 1 over x here, we know 1 plus 1 over x, so x plus 1, so x over x plus 1, so we can write x over x plus 1, x over x plus 1. Now sorry, dy dx. Okay, then now here integral from 0 to 1, 1 over 1 plus x, here we have now we know 1 plus x is a constant, so 1 over 1 plus x. Now integration of 1 over 1 plus y, we know natural log of 1 plus y here from 0 to 1, and here x over x plus 1 is a constant, and if we integrate 1 over 1 minus xy with respect to y, we know natural log of 1 minus xy times, we should multiply by coefficient of y, so here minus 1 over x from 0 to 1. Okay, then here integral from 0 to 1, 1 over 1 plus x, then if we apply limit here, natural log of 2, if we plug in 0 here 0, so natural log of 2 over 1 plus x, then here minus sign, so we know here minus, this x get cancelled if we plug in 1. If we apply limit here, we know we have natural log of 1 minus x over 1 plus x. Here now we have dx. Okay, then we can write this integral into two separate integrals. So here we have 0 to 1 natural log of 2 over 1 plus x square minus integral from 0 to 1 natural log of 1 minus x over 1 plus x square dx. Okay, now this is very easy. Natural log of 2 is a constant, so natural log of 2, and if we integrate 1 over 1 plus x square, we know minus 1 over 1 plus x from 0 to 1 minus, I am going to take this integral is equal to j. Okay, then here if we apply limit, here we have natural log of 2 over 2 minus j. So in this video I am going to give you a homework. Evaluate this integral. I will give you a hint. Take a substitution. U is equal to minus 1 over x plus 1. U is equal to minus 1 over x plus 1. And if we evaluate this integral, this is easy integral. So here we have minus natural log of 2 over 2. So sorry, I skipped that process. I think you can evaluate it. So now if we simplify, this is equal to natural log of 2. Okay, thank you for watching.